I'm Caitlin.
And I'm Jennifer, and this is our discussion on the chemistry of perfume.
We will be going over the components of perfume, molecular structures, perfume is a solution, pH levels, why perfumes expire, and perfume longevity. Based on the book Neurobiology of Sensation and Reward, written by Rachel S. Hers, fragrance is composed of essential oils either from plant extracts or synthetic chemicals, which are classified by structural groups such as alcohols, esters, and aldehydes. Perfumes also have fixatives, which can also be either natural or synthetic, and these help to reduce the evaporation rate of alcohol, increase the strength of odor perceived, and improve the stability. The third component is solvent. This is what the oil will be dissolved in and is typically ethanol, also called ethyl alcohol, with a very small percentage of water. As mentioned, essential oils are classified into functional groups. These functional groups have different structures which can be associated with different kinds of properties, specifically the type of scent. Aldehydes tend to have citrusy scents, esters are fruity or floral, alcohols have more fresh scents, and ketones can have more musky or fruity properties. It is also important to note that benzene rings, consisting of six carbon atoms, have stable and aromatic properties. However, they may not always be present in these compounds because it is the synthetic fragrances which are usually composed of them rather than natural fragrances. An example of a natural fragrance is geraniol, which has a floral rose scent and comes from citronella oil. Its molecular formula is C10H18O, so it contains 10 carbon atoms, 18 hydrogen atoms, and one oxygen atom. It consists of three functional groups, two double bonds, also known as alkenes, making it a diene, and an OH being a hydroxyl group, at the end making it also an alcohol. Additionally, geraniol has multiple isomers, including nerol and citronellol, which also smell like roses, with geraniol being described as more flowery, nerol more fresh, and as citronellol, which is meant to be more delicate than the R isomer. And this is according to the article Pelargonium graveolens and Geraniol by Chris Adams.
Perfume is a solution, which means it's made by mixing one or more substances together to create a homogeneous mixture. The solvent is what makes up most of the perfume. According to Neurobiology of Sensation and Reward, a typical perfume is made with about 98% ethanol and 2% water. Ethanol is great for perfume because it evaporates really easily, so it helps the scent spread through the air without leaving your skin feeling wet. Then there's the solute, which is what gets dissolved into the solvent. That part is made up of fragrance molecules, also known as essential oils or aromatic compounds. These are the ingredients that actually give perfume its smell. They can come from natural sources like plants, or they can be made in a lab. Either way, when you mix them with ethanol and water, you get a solution that is perfume. Something interesting about perfume is that it can smell totally different on different people, and a big reason for that is your skin's pH level. Most people have a skin pH between 4.7 and 5.5, which falls under the acidic category. And that acidity can actually affect both how long your perfume lasts and how it smells once it's on your skin. If your skin is more acidic, citrusy or fresh notes might come across stronger at first, but they'll also fade faster because the acidity speeds up how those molecules break down. If your skin leans a little more alkaline, it might bring out sweet or musky base notes more strongly, making the perfume feel warmer or heavier. Just like any other chemical mixture, perfume can change over time, especially when it's exposed to things like air and light. Fragrance molecules, especially aldehydes, react with oxygen, kind of like how metal rusts. This chemical reaction is called oxidation, and it changes the structure of the perfume. As a result, it can start to smell different, sometimes more sour, metallic, or even kind of rancid. It can also change color. And then there's exposure to light. UV rays from sunlight or even indoor lighting can speed up oxidation and break down the fragrance compounds even faster. That's why perfumes that sit out in the light tend to expire sooner as they lose their original scent and get discolored. To help them last longer, it's best to store perfumes in a cool, dark place away from direct sunlight.
There are also certain factors that can determine the longevity of a fragrance. Some notes, such as amber and oud, have heavier molecular weights and therefore evaporate more slowly. These type of notes can be classified as base notes of a perfume, which tend to be the longest lasting and linger towards the end of the perfume's duration on the skin. As mentioned before, fixatives also help to slow down evaporation rates and stabilize the fragrance. The functional groups ester and aldehyde also increase longevity by forming strong bonds between the oils of the skin and the fragrance. And lastly, skin chemistry is an important factor and differs between people. People with more naturally oily skin or moisturized skin will find that perfumes last longer on them. And that concludes our discussion on how perfumes apply to chemistry and what we learned throughout this quarter. Thank you for listening, and here are our references.